አመሰግናለሁ። አቶ ቀጥታ ደግሞ ቴሌኮም አሁን ላይ ነው ሪሰርቻቸውን የሰሩት ትራዲሽናል ያለውን የቴሌኮም ፍራውድ ዲቴክሽን ሜካኒዝም በመሽን ለርኒንግ ወደ 3 ኦርጋኒዜሽን ተጠቅመው ቴሌኮም ፍራውድ ሜጀር ኢሹ ነው። አዝ ናሽናል ሴኩሪቲ ኤንድ ተቋማቶቹ ራሳቸው ኦፕሬተሮቹ ቢሊዮን የሚቆጠር ገንዘብ የሚያገኝ ነው እና ላስት ዜናዎች ላይ ከሰማችሁ ሜዳ ከባለድርሻዎች ጋር በአደረገው ኦፕሬሽን ወደ ግማሽ ቢሊዮን ብር የሚገመት ኪሳራ ማትረፍ ችሏል። ከዚህ ጋር ቴሌኮም ፍራውድ ጋር የተገናኘ ማለት ነው። ስለዚህ ይሄ ዳይሬክትሊ ከኢንዱስትሪ የተገናኘ ሪሰርች ነው። ሪሰርቻቸው ዲቴይሉ ቴክኒካውን እሳቸው ያቀርቡታል። አቶ ከዲሳ አዳሙ
Okay, thank you. Good afternoon. My name is Gadisa Damu. I'm from Haramaya University, and I would like to thank INSA for for such colorful event, and also I would like to thank and for being here to attend this event, and our project is, or our research paper is detection and the classification of SIM-box or bypass fraud using deep learning, the case of Ethio Telecom. So this is one of the telecom fraud which is done to detect and classify the SIM-box, which is one of the telecom fraud. And these are the author's profile. Me, I'm as I've told you, I'm Gadisa. I'm lecturer at Haramaya University Computer Science Department, and also Dr. Katamadri, Assistant Professor of Computer Science, and also Head or Electrical System Director for the Electrical System, Electronics and Network Science SIG Specialty Group Leader at ASTU, Adama Science Technology, and Associate Professor of Department of Mechanical Engineering at ASTU, or Dr. Janaki Ramlu. So while we go to the outlines of our presentation, so the first one is the introductory part, the second one is related work, methodology, proposed solution, and the result and the discussion, and at the end there is contribution of the research for the company. So when you come to the introductory part, as telecom fraud is the fraud, or that is one kind of fraud which we can attack the operators and the telecommunication company all over the world, and SIM-box or bypass fraud is one of the telecom fraud which will attack, or which will highly attack the telecom company, which international calls are rerouted to, or the international calls are rerouted to the local calls, and as a result the calls become local as the destination. For example, assume you receive unknown call from a local number, and while you answer that phone number, the call is from your friend or your family that live abroad. So this is what fraud, or this is what a symbox or bypass fraud. So while we come to explain how this fraud happens, we have two conditions. The first condition is that the legitimate way or the normal way, and the second one is the fraud way. So to explain how this bypass fraud is happened, assume that there are two callers from different countries, and when the caller in another country calls that to the other, so the country mobile operator will pass the calls and send it through the international gateway to the transit operator, and the transit operator to redirect to the call to the another country or the destination country by using voice over IP technology. So this is how this one is the first one is the legitimate way. That means here is a country A, and while the country A calls to the country B, so here the country A is there, and there is a gateway for country A. Then the transit operator is there. The transit operator will forward this call to the gateway of country B, which is the destination country, and this one is the normal way. But when you come to the fraud way or the fraudulent way, rather than the transit operator, rather than forwarding to the gateway of country B, it will forward to the symbox device. So the call will be local at the destination country. That means here there is a international call, and while it reaches on the destination country, it will be the local call. So this is known as fraud or symbox fraud. And as the main goal of the research, this research is to detect and classify symbox fraud using deep learning by using user CDR data or customer data record that are collected from Ethio Telecom. And this research is aimed to answer the following research questions. The first one is how to identify the features that are used to detect and classify symbox or bypass fraud. The second one is how to differentiate deep learning algorithms that are available in order to detect and classify symbox fraud. And from the identified deep learning algorithm, which one will be the efficient to detect and classify symbox or bypass fraud. So this research is aimed to answer these research questions. So when you come to the related work, as the symbox fraud is harming the telecom company by different ways. So this industry particularly in different, so this is a common problem where there is a difference between international call tariff and local call tariff, such as our country. That means there is a gap difference between international call and the local call. So these are more of interesting part to do a fraud. So different researchers try to detect and classify this fraud by different techniques and methods. However, it have the following drawbacks or limitations. So one is the dynamic nature of fraud. That means when one mitigation actions are happened, so in order to attack again, they will change their behavior from time to time. That means there is human behavior simulation. That means to mimic a legitimate customer. So this is one of the problems. And to overcome, and another one is the concept drift. That means they will again, if one mitigation is happened, they will attack again. So to overcome the stated gap, we have proposed a deep learning algorithm, which will, or deep neural network algorithms, in which capture the dynamic scenarios of, which overcomes the dynamic scenarios of fraud as they change behavior, and train the model with enough data. So in the previous work, there is limitations of data can be as a gap. So and to detect and classify this symbox bypass fraud. So this deep learning will learn from historical data, which is CDR data, customer data records that are collected from Ethio Telecom for the behavioral change and has capabilities into detecting. And so this model will detect and classify the calls as the calls are from the symbox device or from the legitimate customer. So these are the research methodology. So the first one is we have reviewed different literatures. So from these different literatures, we have identified the problem. So the problem is identified problem is the symbox fraud. So In order to solve the identified problems, we have collected CDR data, customer data record from Ethio Telecom. And then we have done data processing. That means the collected data is not, all of the collected data is not important to detect. So we need only the voice data. So the fraud is, the Simbox fraud is one of the frauds, which is take as an advantage which the voice data. So we have pre-processed the data. So we have selected around 12 data features from the collected data. So we have design and implement. So after the design and implementation, we have selected 3 models: MLP, RNN, and LSTM. So after that, we have trained our model and we have evaluated. So at the end, we have used different evaluation metrics such as accuracy, F1 score, and different metrics are also used. So the proposed solutions are, after we have identified the previous related work, or from the related work, we have identified the gaps. From this gap, we have, in this research, we have proposed a deep learning algorithm. From the deep learning, deep neural network model, MLP, LSTM, and RNN. So after data is collected and prepared for the model, we have trained our model in the CDR data of their, and we have compared these models together. So the next slide shows a diagram representations of the proposed solution. So here, the CDR data is there. CDR is customer data record that are collected from Ethio Telecom. So we have done data pre-processing. In the data pre-processing, we have handling the missing values, and the data cleaning happened. So here, the collected data is very huge. So we need to select the important features from the data, from the pre-processed data. We have classified the data as a training data and a testing data. So while we train our model, we have used tenfold cross-validation and the train test split, 80 for training and 20 for testing. And also at the end, we have trained our model, so our model can be evaluated by model evaluation metrics. And the result and the discussion, as I have said before, we have used tenfold cross-validation and the train test split data, 80% for training and 20% for testing. So for both validation techniques, that means for the tenfold as well as train and the test, we have trained and evaluate our models performance. So to measure our model performance, we have applied accuracy, precision, recall F1 score, confusion matrix, and also we have checked the ROC curve. So let's see them. So here, as we have said, we have selected 3 models. From the 3 models, these one are performance of the DNA classification models. That means MLP, RNN, and LSTM for the tenfold cross-validation and for the train test data. So we have get on the tenfold cross-validation, MLP outperforms than LSTM and RNN. Also, when you come to the train test split data, also the MLP outperforms RNN and LSTM. That means we have got around 99.17 in MLP, 98.10 in case of RNN, and in LSTM, we have got around 98.90. So these are the performance of our DNA classification model. So in addition to accuracy, precision, and recall, and also we have applied confusion matrix. That means we need to evaluate in areas such as security and healthcare. We need to reduce the false positive. That means false positive means that when the fraudulent calls are misclassified to the legitimate call, that means if the calls or the fraudulent calls are misclassified as a legitimate call, so we need to reduce this false positive. So our models, so in our case, so we focused on the reductions of FEP, that means false positive, when fraudulent calls are misclassified as legitimate calls. So our classification model best performance by reducing the misclassified false positive instances. So in the conclusion, as the main goal of this research is to detect and classify Simbox or bypass fraud, which will harm the telecom companies, we have selected deep learning from the deep learning DNA models, MLP, LSTM, and RNN. So we have applied both cross-validation technique and the train tests validation technique. So we have evaluated the performance of our models by using different metrics, and generally the overall accuracy of our model was 99.7 for the MLP, 98.9 for the LSTM, and 98.10 for the RNN. As a result, MLP model outperforms than the other two classification models. When we come to the contribution of this research, so this research is have make a substantial contribution for the in order to detect and classify. That means before there is a rule-based, which one is Ethio Telecom now use the rule-based one, which is fraud management system, or also there is a test call generator. So these are this can be have a limitation in order to detect and classify. So these have more accuracy in order to detect and classify this fraud. So it improves the accuracy and efficiency of fraud detection and reducing financial loss for the carriers. So handling large data is also the contribution of this research. That means handling the big data. So this one is data that as Ethio Telecoms have more than millions or in millions of customers. So handling such data is also the contribution for this research. And generally, this study provides significant insight and tools for the telecom companies to efficiently detect and classify these inbox or bypass fraud. So this one is a detection. That means we have collected the data. From the data we have detected. So in the future, we recommend that Ethio Telecom will take this one as to add into their network for their detection, as well as we recommend that if they use a mitigation or a proactive approach that will close or that will detect the calls while they go to their network. So this is all about the our presentation. Thank you. If you have question, welcome.
አንድ ሁለት
ኦኬ አመሰግናለሁ። ጋዲሳ በጣም አሪፍ አቀራረብ ነው ያቀረበው፣ ግልጽም ነው። ሁለት ጥያቄዎች አሉኝ። የመጀመሪያው ታይትሉ ዲቴክሽን ኤንድ ክላሲፊኬሽን ነው የሚለው። ባይፓስ አለ የለም ሊሆን ይችላል። ክላሲፋይ የሚደረገው ግን ምንድነው ነው? ሁለተኛው አንዱ የሪሰርች ኩዌሽንህ ቱ አይደንቲፋይ አትሪቢዩትስ ነው። ዋት አር ዘ አትሪቢዩቶቹ እነማን ናቸው? ፊቸሮቹ በትክክል መኖር አለመኖሩን ሊያሳይ የሚችሉት ነገር ነው። ሌላው ምናልባት አክቹአሊ ሞስት ፕሮባብሊ ደዋዩን ነው ሊሆን የሚችለው፣ በዛ በኩል ያለው ነው የሚያደርገውና ቴክኖሎጂካሊ ምናልባት ግልጽ ስላልሆነልኝ ነው ምንድነው?
እሺ ቴንክ ዩ ቬሪ ማች። እኔም በጣም ነው ማመሰግነው ጋዲሳ። ኢትስ ቬሪ ኢንተረስቲንግ ፕሬዘንቴሽን። የኔም ጥያቄ ትንሽ አሁን ከጠየቁት ጋር ያያዛል። ምንድነው ዳታ ሴቱ ላይ አይ ቲንክ የአትሪቢዩት የታይም ፍሬም ይኖረዋል ብዬ አስባለሁ። ምክንያቱም ኮል ከታይሞች ጋር የተያያዘ ስለሆነ ማለት ነው። ለፊውቸር ፕሪዲክሽን ደግሞ ለምሳሌ ወደፊት ፍራውድ ሀፕን ያደርጋል ወይስ ሀፕናሽን ቴክኒክ ነው የተጠቀምከውና ቴንፎልድ ክሮስ ቫሊዴሽን ቴክኒክ ደግሞ ያለው ፕሮብሌም ምንድነው? መጀመሪያ ሲነሳ ግባል እና ፋይናሊ የምታገኘው ሪዛልት ላይ ታይም ቤዝድ የሆኑ ሪዛልቶች ላይ በጣም አይመከርም። እና ይሄንን እንዴት አየው? ቴንፎልድ ክሮስ ቫሊዴሽን
ኦኬ ለጥያቄያችሁ አመሰግናለሁኝ። ዘ ፈርስት ኩዌስችን ዲቴክት መጀመሪያ ዲቴክት የሚያደርገው ዲቴክት ማለት ኮሉ ከየት እንደመጣ ሲምቦክስ ዲቫይስ ወይ ደግሞ ከሌጂቲሜት ከስተመር መምጣቱን ዲቴክት ያደርጋል። ዜን ባይነሪ ክላሲፊኬሽን ነው እንቱ ክላስ ነው ክላሲፋይ የሚያደርገው። ዛት ሚንስ ዚስ ኮልስ አር ፍሮም ሲምቦክስ ዲቫይስ። መጀመሪያ ሲምቦክስ ስንል ዲቫይሱ ካንትሪ ቢ ወይ ደግሞ ዲስቲኔሽን ካንትሪ ላይ ነው የሚቀመጠው። ለምሳሌ ከአሜሪካ ወደዚህ የምደውል ከሆነ ኢትዮጵያ ላይ ነው የሚቀመጠው፣ ወይ ደግሞ የደዋይ ሳይሆን አለው ግን እዚህ ሲደርስ ኢትዮ ቴሌኮም የሚያገኘው ሎካል ነው። ሶ ዚስ ኢዝ ዲቴክት እንደምናደርገው ኢትዮ ቴሌኮም ሶ ዚስ ኢዝ ዲቴክሽን እንደ ክላሲፊኬሽን የምንለው እሱ ነው። ባይነሪ ክላሲፊኬሽኖች አሉ ማለት ነው። ኮሌክት ያደረግነው ወይ ደግሞ ያገኘነው ዳታ አራውንድ ዲፍረንት ካታጎሪዎች አሉን፣ ሴል አይዲዎች አሉን። አሁን ቤዝ ስቴሽኖች ሴል አይዲ አለ። ከዛ ሌላ ደግሞ የኮል ኢንፎርሜሽኖች አሉ። ለምሳሌ ኮሊንግ ታይም፣ ኮሊንግ ነምበር፣ ኮልድ ነምበር፣ ኮሊንግ ታይም ካርዶችን ብቻ ነው የሚቀበለው። ሶ ያ ሎካል ኮል ሁልጊዜ አሁን ለምሳሌ ሌላ ሰርቪስ የማይጠቀም ከሆነ አንድ ከስተመር ሞስት ፕሮባቢሊቲ ስዋት ፍራውድ ነው ማለት ነው። ሶ ይሄን ነው አትሪቢዩቶቹ እነኚዎች ናቸው ማለት ነው። ኢዝ አራውንድ 12 አትሪቢዩት ነው የተጠቀምነው ይሄን ዲቴክት ለማድረግ ማለት ነው። የሚያጠቃው ለሁለተኛ ጥያቄው ዴስቲኔሽን ካንትሪ ነው የሚጠቃው ብዙ ማለት ኮሌሩ ኦልሬዲ ኢንተርናሽናል ታሪፍ ነው ከፈለው። ዛት ሚንስ ኢን ዘ ዴስቲኔሽን ካንትሪ ጋር ሲደርስ ሲምቦክስ ወይ ደግሞ ፍራውዱ የሚፈጸመው ኢን ዘ ዴስቲኔሽን ካንትሪ ነው። አሁን ለምሳሌ ሳምዌር ከውጭ ሀገር ወደዚህ ሲደወል አታክ የሚደረገው ሎካል ሰርቪስ ፕሮቫይደሩ ነው ኢትዮ ቴሌኮም ማለት ነው። ሶ ዲቫይዙም የሚቀመጠው እዚህ ጋር ነው እና ሌላ ደግሞ እኛ የሰራ ነው ፕሪዲክት ሳይሆን ክላሲፊኬሽን ነው። ዲቴክሽን እንደ ክላሲፊኬሽን ነው። ሶ ፕሪዲክት ያደርጋል ሳይሆን ኖርማሊ ዩዘር ሲዲአር አለን። ዛት ሚንስ ከስተመር ዳታ ሪከርድ አለን። ፍሮም ከስተመር ዳታ ሪከርዱ ወይ ደግሞ የሁለት መንዝ ዳታ ሪከርድ ነው የወሰነ አራውንድ ሚሊየንስ ብዙ ዳታ ነው። ሶ ያን ዳታ ተጠቅመን ዌዘር ኢት ዊል ዲቴክት ዛት ዌዘር ኢን ዛት ከስተመር ኦር ሌትስ ሴይ ከስተመር ኤክስ ኢዝ ቢሎንግስ ቱ ኤ ሌጂቲሜት ከስተመር ኦር ኤ ፍራውድለንት ዋን። ሶ ፕሪዲክት የኛ ስራ ፕሪዲክት ሳይሆን ዲቴክሽን ነው ማለት ነው። ሶ አመሰግናለሁ።
ኦኬ እሺ፣ እናመሰግናለን ጋዲሳ። ያው ፈርዘር ዲስከሽን የሚፈልግ ሰው ካለ ሂ ካን ኮንታክት ፕራይቬት። ቴንክ ዩ።
እሺ እጅግ አድርገን ነው የምናመሰግነው። ሶ ወደ ቀጣይ ፔፐራችን እንለፍ አይደለም። አሁንም አቶ ጋዲሳ ናቸው የሚያቀርቡልን። ቅድም ከድሬዳዋ ያልኩት የስም መመሳሰል ሆኖብኝ ነው። ከሀረማያ ነው ጋዲሳ አዳሙ የነበረው። የሚቀጥለው ፔፐራችን ፊውዘር ዲፕ ፊውዘር ላይ የሚያተኩር ነው የሚሆነው። ዩዘር ኤንድ ሃርድዌር አክቲቪቲ ፊውዘር ፎር ራንሳምዌር ዲቴክሽን የሚል ነው። ይህንን ሞዴሬት የሚያደርጉልን ደግሞ አቶ መሐመድ ፈረጃ ይሆናሉ። አቶ መሐመድ
አመሰግናለሁ። First of all, I would like to welcome you all for the first National Cybersecurity Conference. Today's paper is based on the ransomware. As you know, ransomware is a very common nowadays, a very common cybersecurity hole in the cybersecurity attack, and due to the research paper, it's estimated that it is estimated that into 2023 the overall loss due to the ransomware would be around $20 billion. And in this regard, our traditional way of detecting these ransomware activities were based on the signature analysis and also the traffic analysis. And our researcher has proposed a new way to detect these ransomware activities based on the deep learning CNN algorithm. And our researcher Gadisa Olani is an assistant professor of computer science in Deredawa University. He has his bachelor's degree from Welaga and also his master's degree in computer science from Addis Ababa University. He is also a PhD holder in social network analysis and human-centric computing from university in Taiwan. And he has also 3 national registered talents. And also he has contributed a lot of papers on this regard. Please, ladies and gentlemen, welcome Gadisa Olani to the stage.
Okay, thank you. Yeah, so my name is Gadisa, and I'm from Deredawa University. And today I'm going to share one of my recent research that's called Deep Fuser. So in this paper, I tried to fuse both the user activity and hardware-related activity to detect the ransomware activity. And I outline my talk into 3 parts. And first, I will introduce some general introduction, and then I will talk about the paper, and there will be some takeaways. Okay, so yeah, living in the digital era, we feel that data is like the lifeblood of our business and organization. So realizing the importance of data to the organization, criminals are introducing a new kind of enemy that's called ransomware. So ransomware is actually a malware that infects your machine, and then it will encrypt it, hold your data hostage, and finally ask you to pay for ransom in demand. So as you can take a look at from this picture, criminal will encrypt your file using advanced encryption standard. So to get your data back, you need to make some sort of payment to the criminal. And surprisingly, that payment is going to be made in the form of Bitcoin. So for the law enforcement, it's also very difficult to track where the money is going. So this creates a conducive environment for the criminals. So that's why we are interested to work or address the issues that we are having. So typically, the attack process of ransomware is almost similar with that of other malwares. So it will begin with the infection, and then it will do the systematic scanning. And once it scans the entire drive that you have on your machine, it will automatically encrypt as many files as possible. Because if it makes more file encryption, it will ask for more demand. So it will ask for more money. So once it encrypts the entire file that you have, it will say, oh, I'm here, by showing some README file or pop-up message, which provide information like how to make the payment to the criminal. And there will be some countdown timer that will inform you need to pay the money within a week or a period of days. So this is one of the issues. And typically, to take a look at the impact and consider that one of your favorite hospital get affected by ransomware attack. The consequence is not only about the money. This kind of attack will lead to delayed diagnosis. The same things hold in the banking sector. And of course, financial loss is expected. And more importantly, there will be some reputational damage because as the FBI report indicates, almost 98% of companies affected by the ransomware will not report to the FBI in the fear that their reputation may get damaged. Because, this is intuitive, yes? So let's say one of the bank, which is called A, is affected, and you are the customer of that, and you heard from the news that that bank was compromised. So tomorrow you will take out all your money and move to the next bank. So that is creating some sort of conducive environment for the criminals. And this is statistics almost years ago, and it estimated that the total damage brought by the ransomware is estimated to reach 20 billion in the last year, and I didn't get the exact number for this one, but in 2019 it is nearly 11.5 billion. So there are numerous factors that contribute to their success. The first one is there is introduction of fileless ransomware, and typically the common antivirus will work by scanning the signature of the malwares. But when we come to the fileless, there is no signature that you need to scan and verify for detecting the ransomware. So once the victim invite the malware to its machine, they will retain in the memory, in the RAM, instead of the disk. And then they will try to use the concept that's called leaving of the land. So instead of encrypting the file by themselves, they will inject their process into the legitimate process. Like if you have, I may say, WinRAR or some encryption software on your machine, they will try to utilize that for encryption purpose. So in this way, they will deceive the antivirus or security software that you have. And of course, ransomwares are primarily made for money, so it's attracting more criminals compared to the other types of malware. So this all shows that the existing way of detecting the ransomware is under attack, because if they are all successful, we will note this kind of reports. So toward this, I introduced the concept of deep fuser. So instead of modeling the behavior of each ransomware or malware, why we don't model the change that will take place on our machine when the attack is going on. So, yeah, so actually, when we go to the medical facility, the first step is that the physician will take a look at our vital sign measures, because the increase and the decrease in vital sign measures will indicate whether we are sick or normal. So, like that, I come up with the idea of why we don't model the change that will take place on our machine when the cyber attack is going on. So, like this one. But the key question is that what kind of attributes I'm going to use to do this one? For the patient case, we can use attributes like temperature, blood pressure, something like that. Yeah, then I try to figure out that there are some attributes that are there. And primarily, they are made for different purpose, not for this task. Like, if you take a look at HPC or hardware performance counter that's built in the CPU of a computer, it is primarily made for troubleshooting purpose. But it will tell us more information about the number of instructions that are executed per second, the number of instructions that leads to miss, and so on. Similarly, when the user utilizes the computer, it's possible to capture the number of files that's changed at a time, number of files deleted, modified at a time, or created at a time. So why we don't utilize this for modeling the ransomware? Okay, so the next step is, so I need to make some experiment before going to the real solution. So then I download one of the ransomware that's fileless type, and I download it from VirusShare. Of course, downloading this kind of malware requires permission, institutional permission. So we emailed to them, and they gave us a permission to execute this one. And then I execute ransomware, and I try to observe the change that's made using when we run the ransomware on our machine. So we observe a significant changes in the number of the monitored events, like instruction, branch, cache reference, and so on. So we come up with why we don't model this, the significant changes in those attributes to spot the ransomware activity. You can look at here. We don't care about the type of the ransomware. We are modeling the change that is taking place inside our machine. So this is going to be model agnostic. It's an agnostic solution. So that's the core contribution. And so, yeah, we introduce this kind of artificial neural network architecture. So here we do have two types of data. The first one is extract from the CPU. And actually, there is a tool that will allow us to collect this kind of information. It's called Perf tool. And we have a file management system which will provide us this kind of information in real time. So we can easily intercept the kernel, operating system kernel, to extract all this information in real time. And then, so if we are collecting this data in real time, this will form a time series signal. And then we transform that to the things that we call behavioral image. The behavioral image is like an image that contains a snapshot of the system-wide activity. So here we do have more freedom, but if you make it bigger, just we are waiting for more data to come. So in our experiment, after making some trade-off, we found that 100 milliseconds is better to produce a behavioral image. And then we pass all the entire data through the convolutional neural network, and then the feature extracted from HPC and the file system is merged, and finally we gave that to the dense neural network for classification purpose. So, yeah, you can next it. Yeah, this is something that I already discussed. So, yeah, so the main challenge in conducting this kind of experiment is the data collection. So this is the most difficult part when you deal with cyber security research. So we need to get the file-related attributes, and again, hardware performance counter data. So we need to set up a virtual environment. And of course, there are some publicly government corpus are there from Microsoft or MEPI. So we place those files randomly in different folders. And then we need to collect the benign software, those legitimate softwares, and again, utilize a fake net. This will simulate a network, because if you conduct the experiment even in the laboratory, that ransomware may propagate through the network and it will give some consequence. So we use a fake net, because most of the ransomware will, before making the encryption, they will they will check if there is a network or not. Otherwise, they will stay dormant. So to do that, we use a fake net. And then, of course, we need to have ransomware executables. So in parallel, while executing or doing the daily activity, we collect those data. At the same time, we run the ransomware one by one. Of course, some automated tools are there, like Cuckoo Sandbox. Please return to the previous slide. Yeah, thank you. So there are Cuckoo Sandbox are there. So, but I found that emerging ransomwares are able to detect the environment to which you are running them. They are able to detect if you are running it in the laboratory. For example, if your PC name says Lab 1 or university name, they will stay dormant. They will not activate. So you can't capture their behavior. And again, you need to change that things again and again. Even sometimes they will ping the country. I also come across one ransomware that's called Jigsaw, and it will not work in Ethiopia. And I go through the website and found that they have a country list. So maybe they don't feel that we will pay them. So they will not execute their malicious task in some countries. So I tried to use an automated one. At the same time, manual execution is also there for building the system. So my first experiment is like this. Given a random sample of any consecutive milliseconds of system-wide activity, what is the performance of the proposed model in terms of precision? So you will give the model 100 milliseconds samples of fire-related activity and hardware performance counter-related activity, and then it will tell you the probability that the current sample belongs to the ransomware or the normal one. So the finding seems good, because the reason is that we are modeling the change in the hardware attributes instead of modeling specific random ransomware attributes. At the same time, we try to compare our work with 2 state-of-the-art ransomware detection solutions. And actually, I emailed them, and they shared their GitHub link where they implement their code. So it is very easier for me to compare my work with their works. So every parameter and every setting that they made is already on the GitHub. And the second experiment is just, I wanted to evaluate how well deep user performance on ransomware families that it has never seen before. And actually, this ransomware is like constitute 1/3 of ransomware in the wild. They are the most challenging and again the most frequent types of ransomware. And most of them utilize the multi-threading to execute the encryption tasks as soon as possible. So then, yeah, of course, I observed some reduction in the performance and with regard to like false negative rate. So there is a slight drop in terms of false negative rate, but still that's acceptable. So from this one, it is one understand that modeling change in system-wide activities with a deep neural network, it's possible to distinguish the ransomware activity from the benign one. So maybe as a takeaway, of course, in the old time, when we lock our bike or other things like this, just we feel that it is secure. But now, the criminal always try to fly under the radar. Yes. So in the first picture, just the only secure part is the front tire, and the other body of the bike is vulnerable. So maybe after you come back from the shop, you will come up with these kind of things. The same things happen in the security. There is no absolute security. So the best way is just you need to have a layered method of defense, prevention, detection, and again deflection, or different things needs to be combined to have a strong security mechanism. So maybe for the other researcher, I believe that the next challenge is to be about the the AI-generated cyber attacks. Yeah, of course, last year we were amazed by the introduction of ChatGPT and other models. But in the future, malware criminals or cyber criminals may start using the GPT, or they may introduce a new version of GPT. They may call it malware GPT. Imagine, there are data set of malwares out there, and if they are going to use that for generating new variants of malwares, which is going to be very difficult, because in a day they may produce hundreds or thousands of malwares at the time. So the next research direction may be how to defend AI-powered cyber attacks. That will be the future research. And of course, I'm willing to collaborate, and I have nearly more than 6 experience in cybersecurity related research, and so that's all I have, and thank you.
Thank you, Gadisa, for your brief introduction about the paper, which is amazing. Next, due to time constraint, I will provide 1 or 2 questions for the participants. Okay.
Okay, amasaginaalo. First of all, Dr. Kandisa, thank you for your very interesting presentation, very specific and current security issues. Normally, I have no such questions for you, but and also I recommend you, or based on your talent you have, I understand now, if you do also on preventions of such the size of data set to measure those accuracy, F1 score factors and etc. Maybe. And lastly, if you show us such your metrics also determined, or it is performance also determined. በመጨረሻ ላይ ቢሰራ ብሎ ኮመንት ሰጣለሁ። አመሰግናለሁ።
እሺ አመሰግናለሁ። ያው የመጀመሪያው ኮሜንት ነው ፕሪቬንሽን ላይ ቢሰራ ብላል። ሜቢ አውድ ለማድረግ የራንሳምዌር ብዛት መጀመሪያ ላይ እንደ ችግር የነበረው ምንድነው? ራን አርገም አይሰራልህም ወይ ራሱን ያጠፋል። ዳውንሎድ አርገ ኤግዚኪዩት ስታደርግ ኢንቫይሮንመንቱን ይማርና ራሱን ያጠፋና ጊዜ የሚበላ እሱ ነው። ችግር እሱ ነውና በአጠቃላይ ወደ 400 ራንሳምዌር ነው ማኑዋል ኤግዚኪዩት የተደረገው። ኩኮ ሳንድ ቦክስ አሁን የተለመደ ነው፣ በሱ ነው ኤግዚኪዩት የሚታረገው ከዚህ በፊት። ነገር ግን 10 ራንሳምዌር አላገኘውም በዛ ውስጥ የሚሰራው አውቶማቲካሊ ጊዜን አላባክንም ማለት ነው። አይሰራም ወይ ማታ ሊሰራ ይችላል። ቶሎ ቪርቹዋል ማሽኑ ወደ መጀመሪያ ኢሜጅ መልሳለሁ። እንደዚሁ ኪፕ ካላረኩ አጥፍቶ የተጠቀምኩት ማለት ነው።
Thank you, Gadisi. Please, a round of applause for Gadisi.
እሺ አቶ መሐመድ እጅግ አድርገን ነው የምናመሰግነው። ወደሚቀጥለው ፔፐራችን ነው የምንቀጥለው ማለት ነው። የሚቀጥለው ፔፐር ብሎክቼን ቤዝድ ኤዱኬሽናል ዶክመንት ፎርጀሪ ዲቴክሽን ኤንድ አውተንቲኬሽን ሲስተም ላይ የሚያተኩር ይሆናል። አቶ ካሳዬ ታፈሰ ሞዴሬት ያደርጉልናል።
እንዴት ዋላችሁ? በቅድሚያ እንኳን ለአራተኛው የሀገር አቀፍ የሳይበር ደህንነት ወር በሰላም አደረሳችሁ ላለው እንደምታውቁት የዚህ አመት የመሪ ቃል አይበገሬ የሳይበር አቅም ለሀገር ሉዓላዊነት ነው። አይበገሬነት ወይም ሬዚሊየንስ የሚፈጠረው በዋናነት 3 ነገሮች ላይ መስራት ስንችል ነው። ይሄም ሰው ላይ መስራት ስንችል ነው። ይሄ ምን ማለት ነው? እንግዲህ የነቃና የበቃ የሳይበር ደህንነት ራሱንም ሌሎችን መከላከል የሚችል የሰው ኃይል አቅም መገንባት ስንችል በመቀጠል ደግሞ ሁሉንም የምንሰራቸው የአሰራር ይዘቶቻችን ላይ የሳይበር ደህንነት ስጋትን መሰረት ያደረገ መሆን ሲችል በመጨረሻም ቴክኖሎጂ ላይ መስራት ይገባል። እንግዲህ ቴክኖሎጂ የችግሩ ምንጭ እንዲሁም የችግሩ መፍትሄ አካል ናቸው ማለት ነው። ሶ ይሄንን ካልኩኝ በመቀጠል በሶስተኛው ፒላር ላይ ወይም ቴክኖሎጂ ላይ ጥናታዊ ጽሁፋቸውን የሚያቀርቡ ሁለት